I would now like to welcome Professor Dr. Sadiq R. Malik, ex-professor and Chief Radiation 1 physicist from the United States of America, to deliver his keynote speech. Thank you.
Assalamu alaikum and good morning. You have heard from Dr. Billah and our respected guest, Professor Nazrul Islam, and in their absence, I thank all of those eminent participants and attendees. It is difficult to talk about Al-Biruni in a few words. In other words, you have heard most of the peripheral information about Al-Biruni. But Al-Biruni was not like that. I intend to bring about things that he made himself the greatest of all scientists and for human civilization. Having said that, I would like to go into my space, but as you said that my slides are not here to say something. It is not a pleasure to talk about somebody who had been here 1,000 years ago. 1,000 years ago. Since then, I will try to bring about a logistic of meticulous information which brought Muslims in the dark for a long time. The title of today's speech is Digital Basis of Natural Phenomena by Conceptual and Numerical Analysis. Some of you who think about concept and numeralization of that concept into reality will understand simply like this. I don't want to go into the depth of matter, but some of it. So we used to say long time ago, I have a force, I am working harder, and I have an acceleration, I can speed up. But these things were a concept. But then some scientist, including Al-Biruni, brought out some numerical analysis and equations to bring about the measurement of force, acceleration, gravity, and so on and so forth. So the concept realized in numerical or functional matter is a great contribution. Why? Because it is reproducible. I have a greater force, I can reproduce it with some equations of science. Having said that, I would go into the details of some of the parameters Al-Biruni contributed for the human civilization 1,000 years ago. Next is, as you know, the impact he made, science, astronomy, mathematics, physics, philosophy, natural sciences, including psychology and medicine, and made Al-Biruni the greatest scientist of all time. I just want to mention to you that we have, since Alfred Nobel declared the Nobel Prize, we have so many Nobel laureates of distinguished contributions to the human civilization. But Al-Biruni in one had so many disciplines to tackle with. It is the great mind, how one person can have so many directions and depth and contribution. For example, the Nobel laureates of today may be expert in genetics, microbiology, whatsoever, but they did not have, or they do not have, a multiple expertise and depth in all matters of science, which is introduced here on Al-Biruni. Having said that, what impact did he have on human civilization? I'm talking about this on human civilization. Now, theoretization, he had to conceive the matter, experimentations, he had to develop some experiment to prove it, and then instrumentation and evolved following him. He pioneered many present-day applications to quantization in advancing our civilization. Even he, just to bring about earlier on now, he had the analog side to make it some computer situation in the beginning of that 1,000 years ago. Next, this is a picture. Some of my Iranian friends will know that the turban Al-Biruni had changed a lot of today. You know that we use head caps in every country, every culture. But Al-Biruni had something which most of the Iranians are not using today. So this is just to show you how time flows, how we change ourselves and we attire ourselves with different things. Al-Biruni, as I keep telling, in 1048 he died. He was born in kingdoms of today's Uzbekistan, Kazakhstan, Turkmenistan, and Ghazni was at that time the capital of Ghaznavite dynasty. To study astronomy, Al-Biruni settled in Al-Rabi near Tehran in 1017. He's only 44 years old, or about 40 years old, and traveled to India to study Indian science. So therefore, his contribution came not only by himself, but he was traveling, acquiring knowledge, and having the concept and applications of numerical analysis. He was a universal genius, as you heard already, and his work number is 146. So this is a vast number, but look at the numbers I tried to show you. He has 35 books on astronomy. I mean, he had great knowledge, 4 on astrolabes and equipment to study the coordinates of Earth, and then sun and celestial bodies. 10 on geodesy. Geodesy is a science of mathematics which talks of the shape and size of the Earth and also bigger objects. So he had these multiple things. Then 15 on mathematics, 2 on mechanics, 2 on medicine and pharmacology, and 1 on meteorology. He said something about the changes of weather. 2 on mineralogy. He could find out the minerals and the specific gravities. So these are the very intricate experimentation. If you know, some of you are good science, in mineralogy, make a slice of a mineral, it has a beautiful color. That kind of phenomena must have occurred to him, so he could study the specific gravity, which in other words, the density at that time for different minerals. All minerals are not the same. They have different densities. I don't want to go further into technical matters, but as you see, he has 16 literary works, 2 books on magic, and 9 unclassified books. So most of the books, as you have heard, have been not available now, maybe burned somewhere, sometime historically. He was the first to obtain simple formula for measuring the Earth's radius. And I'll try to bring this point again. And then he deducted the Earth's possibly revolve around the sun, solar year of Hipparchus and Ptolemy is so many days and minutes, but Muslim astronomers then only had a few 10 minutes difference from them. So Al-Biruni's ideas of universe is strikingly similar to that of Einstein and modern scientists. What I'm trying to say here, that his ideas of the universe differed before other scientists like Aristotle and others. So therefore, it is the great courage to defy the existing environment and say what you want to say. So therefore, Al-Biruni was, in mental attitudes, a very courageous person at that time. Al-Biruni, as we keep telling you, 146 tides, he lived only 75 years. And Newton lived 84 years age, and the other one, Einstein, lived only 75 years, or 76 perhaps. So therefore, to have this enormous contribution in books and sciences, he was very, very different kind of person of great mind. But as we have seen, most of the contribution was in astronomy. So therefore, what he came back here, the concept came, the numerical analysis followed, and the quantization. That quantization, I will show you in a minute, that developed the rudimentary ideas on computers. So experiments and numerical analysis of natural phenomena. He made the theories first to proclaim reproducibility of the matter. Then he said experimental observations of Al-Biruni's original contribution, and then, of course, the instruments and numerical analysis. These instruments and numerical analysis, I'll come back to it later on, but you see that he was not only a theoretical philosopher, he was an experimental or applied scientist. So this is a great achievement. In many departments here in the United States, we have applied science, we have theoretical physics, so on and so forth. But you see, in one mind, so many compartments of science was traveling, and that's why he's the greatest of all times. Then, of course, the conclusion. I'll try to speed up further. My previous speakers have taken most of the exciting speech for you, but I'm going to down to earth on this. So therefore, it would not be sufficient to tell greatness of him. Rather, there is some books and treatises that he left behind could be of these. These are the famous books, Qanun al-Masudi, as you have heard, Kitab al-Hind, Adhan al-Baqiya, and so on and so forth, and you go up to mathematics and astronomy. I was a bit lucky, I think. I don't know about other speakers. I could get most of the Al-Biruni's books in United States libraries. Because although they are not Persian or something, but the books for Al-Biruni was there. So therefore, I was able to say a few things on him now. Now, this is the famous thing. If you think it is just a simple matter, it's not. That time, everybody used to see there is sun eclipse, moon eclipse. There is a moon becoming full moon or the crescent. All this sort of thing. But nobody could explain why it is so, why there is an eclipse, why there is a tide. So Al-Biruni was the person who developed this famous picture. If you see about any writing on Al-Biruni, it will be there. So therefore, the moon phases are given in a very sweet manner, where sun, moon, earth is more revolving around the sun, and moon is revolving around it, and therefore they overlap in their path, and therefore you get the full moon or the new moon or the dark moon. Having said that, so it goes major phases in the moon. I am sure you know the new moon. I'm not going to take your time a lot. Waxing, when it is increasing, decreasing, and then of course the last quarter is a half moon, and moves like the crescent, and the crescent decreases in size from one day to the other. So those phenomena were concept, but he produced a diagram and the explanation for it. That was remarkable. Now, this is just to highlight, because some of you don't know Persian. So there's the sun is here. Sun is here, I think. And yeah, you can see that. So the revolving of Earth and Moon are given in this diagram. Just a duplicate to help us out. Now, this is the planisphere you talk about. It is the instrument you talk about. That is the astrolabe. Qanun al-Masudi discusses the planisphere. What it does, if some of you who don't know about planisphere as it is something you look at the fixed star, then look at the unknown object, and therefore you know the locations in spherical coordinates or angular coordinates. What I'm trying to say, the angular coordinates was the concept in demarcating the coordinates or the location or the position of celestial bodies. So if you can imagine how great a thinker he could be, he could see something which was not available at that time. This is the gear system, which you know that this is the lunar gear that tells you about the solar calendar, why the day forms, when the day is, the time of the day, this sundial and everything. So this is something very remarkable, and I'll show you later. So other notable works, Al-Baqiya, Kitab al-Saidina, Materia Medica, Kitab al-Juhair, the jewels and things and stones, and numericals. Having said that, this instrument you see here, I was teaching in America, then we had it, one ancient one, it's called the gyroscope. When the Earth is moving in its own axis, this, and the sun, revolving around the sun and all that, all are depicted in that instrument. Al-Biruni was the first scientist who had calculated and given the correct values of latitudes and longitudes of Earth at various places. He was the first scientist who established the fact that the speed of light is far greater than the speed of sound, which is very true. And the speed of sound depends on a media. If it is vacuum, it does not travel. So therefore, in order to determine the motion and position of Earth, Sun, Moon, and various stars, he established, with the help of Muslim states, several well-equipped astronomical observatories. You have heard of observatories today, and therefore it was the brainchild of Al-Biruni at that time. I don't want to go into the formalities or the technicalities, how he used it, but there are hundreds of observatories around the world looking at the stars at the far end place and discovering many planets which you know today. Even that there is a Nobel Prize on a new satellite star in the sky. So therefore, having said that, he determines the motion of the solar apogee or the point of the orbit of the sun in space when it is farthest from the Earth. He corrects Ptolemy's findings. This is where the boldness comes in, where he employed mathematical technique unknown to his predecessors. So please note that he shied away from previous scientists on this matter. So he used mathematical technique and also the instantaneous motion. Motion could be accelerated or just continuous. Therefore, he could define the instantaneous motion, the acceleration, and therefore that he had something, mathematical functions, as you see in red color over it, to have these concepts into reality. So Muslim scientists recorded about 32 from 700. So I just thought it is very interesting. You have heard our speakers. There are about 32 Muslim scientists from 700 to 1500. After Prophet's birth, that is very close to 700 to 1500, then we had all the developments from Muslim scholars. And Al-Biruni was the 18th in succession of the Muslim scientists at that time, which is about 973 to 1038. And then there are the end of Muslim scholars was number 32, which is Muhammad Turgal Ulluk Beg. And therefore, that, as you heard, that since 1500, what happened? Then Newton came in 1600, 200 years later, and Einstein, and they contributed lots on physics, astronomy, optics, calculus, followed by 100 specialized scientists of modern world. If you can look at these things of a couple of 100 years, what happened to Muslim science? It's a dark era, as you have heard, and I just wanted to show you that he was only 18th in succession, 32 total Muslim scientists at the time, and then we had a darkness, we slept all through, then Newton came up, and also Einstein, and so on and so forth, and the big scholars. So this is the fact we have to reckon with. If we want to get lost, we can get lost, but we need to revive ourselves and get up. So I don't want to go further on this. There's a lot of things I can talk about. The heliocentric movement of the Earth. Earth moves around itself and around the sun. So therefore, those are the very interesting experimental data. Therefore, before that, if you have gone through certain part of the history, Aristotle and used to say the heavenly body moves in circular orbits or possibly elliptical orbits. It is an ellipsoid. So therefore, theoretical mechanics introduced the concept of physics, dynamics, and friction acceleration is a non-uniform motion. You heard about it when Newton came in 1642. Non-uniform motion, that is accelerated motion or decelerated. So these concepts are very profound. But you know what Indian culture at that time was astrology. I know I was in Nepal, and the king of Nepal used to have all his astrologists in the morning to show him what he should be doing today or tomorrow. And he died that morning, and he never knew all the astrologists are there to predict that he's going to be fine on the day. So I was there by chance, and therefore I was wondering, is astrology a very great thing? And he said a long time ago, 1,000 years ago, that it is as methods using conjectural rather than empirical, just make up science. And therefore he never really liked the astrologists. So having said that, on the mechanics side, we all walk and we have a friction on the shoe. Without that, you will always slip, and therefore, that is not a thing. But he understood. We all walk, but do you know how much friction do you have with the floor? And therefore, when you slip, it becomes slippery. You fall when you not walking with a good shoe. So the friction, dynamics, and motion of the earth, everything remained a very powerful concept from him. So therefore, the next point is the motion of sun. He invented astronomical instruments, and the Milky Way, which is very true today, the solar and lunar eclipse he observed from Kabul and Kandahar. So those are the experiments he could devise to understand the solar and lunar eclipse. So these are not the thing that he borrowed from somebody, it was his own creation. So therefore the experimental observations where he used angles and trigonometry, the polar coordinate, these are the very interesting things they happen. Then he found a specific gravity of 18 elements, and he worked on shadows of chords and circles, the sundial, and therefore, look at this. They explained natural springs and artesian wells. The Jamjam water is an artesian well. He could see the hydrostatic pressure that makes it happen. So before that, everybody knew there is a good fountain, from the mountain, but he developed the idea how it happens. So this is called the hydrostatic phenomena. He was aware of that. So in astronomy, instruments to understand all these things, as I said in the beginning, he had the theory, then the concept, then the applied thing, the instruments, and all that thing. So the prayer we make 5 times a day, that time was decided by him and the Qibla also. And I can go on. He's on saying that he gave the conception of polar coordinates that time. And therefore, he could see the location of any object or heavenly bodies through his ideas of coordinate system. Optics, he didn't go very further on this, but he said he postulated the speed of light is finite. He never said that it is infinite. And he said speed does not accelerate. You get a constant speed of light. It does not travel from the start to here, accelerating itself. It is the same speed down from origin to fall in earth. So this is a remarkable thing. When I think of it, I never realized that how it was possible 1,000 years ago, to go for that. Now, in instruments, as Dr. Billah said, that the Earth's radius was only 16.8 kilometer less. It is 0.3% of today's value on Earth's radius at that time he made. So therefore, note statistics. We will believe in statistics. We are happy if we have 2%, but he has 0.3% difference 1,000 years ago as of today, the radius of the Earth. Then you have something interesting, the mineralogy. I mentioned so many times. Physics, he's talked about gravity, and he said the experimental psychology. You see, this is interesting. Psychology. Now, you know, for the student of psychology, there's a thing you can measure the reaction time. Say we have 100 people. I have an experiment I have done in my class in the United States where I could see which student has a faster concept than or reaction time than that. Like you are driving a car, how fast you can react to certain dangers. Those are things were known to him, and know that the psychology was simulations of the organ and conscience. So you see, he could hit the point which makes it available, which is experimented as reaction time. Okay, how fast you could be. Then, of course, the chemistry, he rejected. This is interesting to me. I don't know, some of you might be thinking. Long time ago, the chemist said, I can make gold out of something. But he said, no, you cannot. Now we can. We have the nuclear machines which accelerate and break an atom and make a new atom, new kind of atom. So therefore, in chemical point of view, he was correct. He didn't have the idea of accelerating an atomic particle into enormous mega electron volt to break up another atom to make a new atom. So therefore, from chemical point of view, I admire that he said very clearly that you cannot have a new element by chemical means. Chemical means have very little energy. The results from mathematical equations, 600 years before Galileo, Al-Biruni discussed the theory of the Earth rotating about its own axis. So Galileo came 600 years later. Before that, he said that, and Galileo substantiated his findings. The astrolabe is a nice instrument, and I wish we had something in here. We didn't. I have used it, and that you will focus something on a kind of intervalometer, or you can call it a quadrant, and then look at the deviation of one object in this heavenly bodies to another. So therefore, he developed that instrument, and it's now you can go to Amazon.com and buy a lot of astrolabes of different colors and things. So therefore, it is available now. Now, his book on Tawhid, the determined coordinates and cities, that is important. Then he determined the local meridian, that is important. With the aid of mathematics, he also enabled the direction of the Qibla. All goes to coordinates, all goes to the geometry, all goes to the concept of trigonometry. So therefore, he had the profound synthesis of mathematical functions to describe the Qibla, direction, from any part of the world. Now, just to make sure that we are talking some sense here, it is the hill, E for elephant, is the hill there. If you make some projections, then you get OT, and that line is the radius of the Earth. So therefore, he could see the radius, he could see the circumference in a very definite way. And you remember, I told you already, there is 0.3, decimal 0.3% difference from 1,000 years ago to today. So it is something, I don't know how many Nobel Prizes he would have given if he lived today. Then this is the quadrant. This is very common. Any builder would have it. And therefore, the plum thing that tells you that it is always pointing to the gravity, central gravity of the Earth. So therefore, nobody can touch it. So therefore, quadrants, astrolabes, and clocks. These are the three contributions. I'll not go very further. It takes quite a bit to explain that. Now, this is something amazing. If you kindly make a note of this, Al-Biruni crater. Now, when I worked with the Apollo 17 moon rocks and Apollo 11, these two moon rocks, but Apollo 17 has a peculiar understanding. that it was a orange soil, orange. When you impact sand, earth, for example, like a rice crater in Germany, then it gets melted and becomes a new element, new crystal. Like you produce a glass out of burning it to high temperature and solidifying it. Are you able to follow me? So there's the big science behind it. So therefore, the reason I'm talking about Apollo 17, that we had the orange soil. We had other parts of the moon rock that was of different color. So we wondered what happened. Now, Al-Biruni was so famous at the time in our scientist astronomical world that they made this Al-Biruni crater. That you see can you see that there is a kind of crater in the middle, and the big one is the crater, and there is a small depth in it. So therefore, they made it the Al-Biruni crater facing north from Apollo 17, space shuttle. I will show you further on this. I was intrigued when I looked at it. The oblique Apollo 14, it was taken by German camera, which is Hasselblad camera image. So we developed ourselves so much that we could see a crater which Al-Biruni predicted, and also the size of it. Then, of course, the quad function you are hearing all the time today, and this, you can have the sine function, quad function, theta, radian. You can see the sine function has a highest point, which is 1 at 90 degrees. Some of you who know trigonometry, you will agree that these functions are developed from the simple trigonometrical classification. Now, this is the trapezoid. This is kind of a spherical object. If you project it, it becomes a method. It takes a method which gives you the latitude and longitude of the object. And some simple equations are there. It intrigues me, but some of you who are good in mathematics may be able to step up. So therefore, the figures of astrolabes and the plumb line and all those things you have seen right now, they would go, let me see that this is the planisphere. It's very, very, very intricate diagram. I'm sure what he did, that one position, one star at a time, he developed the whole of it at different angles. So therefore, it takes a long time, but these are the basic analog computer ideas. It's kind of a laptop at that time. So therefore, I said the numerical analysis, the concept of it, and therefore the digitization started from Al-Biruni. And that's why I said that the concept was driven into mathematical functions and some instruments. So there were three things went hand in hand in the minds of Al-Biruni. Now applications, the astrolabe is a good application. Gears are a good application. Therefore, the gears, I don't know how many of you realize, some of the watches you buy, there are a lot of wheels, second, hour and minute, and therefore those wheels are not of the same diameter though. If you look at it carefully today in the shop, they have different shape, different radius, and also different hook spikes, so that one moves, the other does not move that fast. And that's how we get the minute and second and the hour. Okay, some of you who have thought about it, whether you're a man of science or not, the gear has a profound impact on understanding time and sundial and everything. Having said that, I wanted to show you that Ibn Sina was the profound medical scientist at that time, but he dedicated 3 chapters on Al-Biruni's psychiatric disorders. I talked about the reaction time. Why we react faster, why someone is slower, and so on. It is the mental thing, it's the biological function that has to be triggered to give a reaction time. Having said that, you can see that it is, I'm talking about his work of 1,000 years ago from today, he suggested about the Caesarean operation, and that on a dead woman, and you know that it is recorded in Al-Baqiya in Edinburgh. Having said that, this conclusion, I must read it for you, the legacy of Al-Biruni. I'm trying to hurry up so that you don't lose patience. No history of mathematics, astronomy, geography, anthropology, or history of religion to complete without acknowledgement of his immense contribution. Can you read that? So therefore, one of the outstanding minds of all times, distinguished to a remarkable degree by the by the essential qualities which have made possible both in science and social studies and biology. Al-Biruni is the example of the universality and timelessness of a great mind. In his own words, Al-Biruni was a Muslim scientist who benefited from the Islamic guidance and scientific investigation. He said, I'm sure some of you who have this book, it is on the top of it written, in the name of Allah, the creator and of the soul and wisdom. Now look at Al-Biruni's concept. He never pronounced Allah. He never pronounced, God, but his description or definition of Allah is, my experience, if you can read it, my experience in the study of astronomy and geometry and experiments in physics revealed to me that there must be a planning mind of unlimited power. My discoveries in astronomy showed that there is a fantastic intricacies, not simple, intricacies in the universe, which prove that there is a creating system and a meticulous control that cannot be explained through sheer physical and material causes. So therefore, one can understand that he defined Allah. And some of you who believe in the Creator, also in the book I saw, we know now how he defined it, not just saying it, but he defined it from his perception of his knowledge. Having said that, I must have a simple quotation for you. I see that a lot of our benefactors are here, but once a sage, a pious man, asked why scholars always flock to the doors of the rich. And why, all the scholars go to the rich, as Dr. Arif Billah told us, that he went to many, many industrialists and so on and so forth, but his experience is negative. But the question was, once the sage asked why scholars always flock to the doors of the rich, Al-Biruni said, what is the rich are not inclined to call at the doors of the scholars. So therefore his answer was, the scholars, he answered, are well aware of the use of money, but the rich are ignorant of the nobility of science. So you can see, which he said 1,000 years ago, it is very true even today, what we see. So therefore, I thank you all, and therefore this is a big mind. It is not possible to show all his capabilities. Rather, I concentrated on the science and astronomy and the functions and reproducibility of his work over the 1,000 years. My question to you all, as before, we finished him with the Muslims finished within 1,500 years, but then we remained dormant, so still today. Newton came in 1642, and that's the start of some other science and mathematics as we know today, including calculus. So therefore, thank you.